So what is meant by an object's center of mass? Well, before we dive into this flashcard, let me give you a little illustration. Let's say you wanted to carry a ladder. Where would you carry the ladder on your shoulder? Would you carry it in the center of the ladder or the middle, just like this chap is here? Or would you try and pick it up at the end and try and balance it on the end? Well, our intuition says that it would be best to pick it up in the middle, because we know that the anti-clockwise turning effect would balance the clockwise turning effect, so that we could balance this beam effectively on our shoulder. But if we can also think of it in a different way. This ladder has got millions and millions of different parts, of different masses, molecules or particles, and each has got a mass. And if we were to add up all of those masses, and would get the total mass of the whole ladder. And if we average the positions of all of these masses, then they would occur somewhere in the middle of the ladder. Please ignore the man for the moment. I'm not targeting him. If you just ignore the man, I'm talking about the ladder. And all of these masses will seem to act as if they are concentrated at this point here, called the center of mass. That center of mass has a weight, and that weight is conveniently located directly below the pivot, so that this beam is balanced. So let's define the center of mass and mention the center of gravity at the same time. So center of mass. The center of mass is the point at which all of the object's mass seems to be concentrated. Center of mass is the point at which all of the object's mass seems to be concentrated. So all of these little pieces of the jigsaw puzzle here, 0.1 kilograms, we add them all up, we get 0.6, and we can replace this jigsaw puzzle by a dot, a center of mass symbol, which is looking like a little BMW sign. And so this would be 0.6. We wouldn't have to worry about the shape of this jigsaw when we're doing calculations. We could just treat it like a dot, a point in space. And that makes calculations a lot easier in physics and in engineering. So that's the center of mass. And while we're at it, we need to just talk about the center of gravity, because gravity will act on that summary of all of the masses, and that would be through the point through which weight appears to be acting, and we call that the center of gravity. So the center of gravity, and it's the same point, is the point at, or rather through which, we should say, point through which the whole weight of the object seems to act. It's like a summary of all of the weights. We can just replace it with one force acting downwards at that position. And just to make a note, they are at the same position. They're the same position, just different ways of looking at it.